Hi guys, welcome to my YouTube channel. I'm with Daniel. In my previous video, we saw the introduction to the numerical ability. In this video, we will see how to calculate the number of divisors or factors of a given number. So for example, here we have a number 6. So and we have to find the factors for this given number 6. We go by conventional method. We have to see what and all numbers divide 6 completely. So here the 1 divides number 6 completely, 2, 3 and 6. So these numbers divide the number 6 completely. So there are total 4 number of factors which are dividing the number 6. Again we take another example. It's a little bigger number like 144, and again if we want to go to by conventional method, it takes a little time to find the factors of a given number. For example, here 1, 2, 3, 6, 8, 4, 9, 12, 16, 18, 24, 36, 48, 72 and 144. These numbers divide 144 completely. So if you want to find the number of factors, we have to count these factors: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are total 15 number of factors of a given number 144. So 15 factors. So when the number is big, it takes a little time and very difficult to calculate the number of factors of a given number. That's why we go by an easy method. And so here easy method is if a number is given, to find out the factors of the given number, so we have to express it in the form of the product of their prime numbers along with their respective powers. So we have to express it in the form of a to the power p into b to the power q into c to the power r, where a, b, c are their prime numbers and p, q are respective powers. So then after expressing it, in order to find the number of factors, we have to multiply their adding 1 to their respective powers, and then we have to multiply in order to find the factors p plus 1 into q plus 1 into r plus 1. So let us take the same example here, 144, and we have to express it in the form of a to the power p into b to the power q into c to the power r as a product of prime numbers. So how to do it is, we take 144 here and we will not find out the prime numbers. We will express it here: 2 36, 2 18, 2 9, and 3 3. So here we have expressed 144 in terms of prime numbers 2 and 3. So it can be expressed as 2 to the power 1, 2, 3, 4. So 2 to the power 4 into 3 to the power 2. So we have expressed the given number 144 in terms of a to the power a, b into b to the power q. Here p is equal to 4 and q is equal to 2. So we have to, in order to find the number of factors, we have to add 1 to their powers and multiply them. 2 plus 1. So here 4 plus 1 into 2 plus 1 will plus 5 into 3 equal to 15. So the total number of factors of the given number is 15. Another important note is here that whenever the number of factors we get an odd number, then the given number will be a perfect square. Here 15 is an odd number, then the given number 144 will be a perfect square. 12 into 12 is a 144. So here the 144 number is a perfect square. So let us take another example. Find the number of factors for 3 lakh. So here we write down 3 lakh and express it in the form of prime numbers. So here 2 ones are divided by 2 and we'll get the quotient. Here we will divide it by 3 and here divided by 5. we have expressed 3 lakh in terms of prime numbers, 2, 3, 5 and 2. So here we take this 3 lakh, we express it in the form of A into the power B, P into B to the power Q into C to the power R. So here we take it 2 to the power 1, 2, 3, 4, 5. So 2 to the power 5 into 3 to the power 1 into 5, 1, 2, 3, 4, 5. So 5 to the power 5. So after expressing it in the form of A to the power P, P to the power Q and C to C to the power R, we will multiply 5 plus 1 into 1 plus 1. Adding, we have to add 1 to their respective powers and multiply them to get the number of factors. 6 into 2 into 5 plus 1 6, 5 plus 1 is 6. So 6 6 is 36 into 2 we get 72. So the total number of factors of the given number 3 lakh is 72 and it is a even number. That's why this 3 lakh is not a perfect square. So here we will take another example. Find the number of factors for 14,40,000. Here we expressed this number in terms of prime numbers as usual by conventional method, and then here we express it in the form of A to the power P into B to the power Q into C to the power R. So here we will express it as 2 to the power 1, 2, 3, 4, 5, 6, 7, 8, 2 to the power 8 into B to the power 3 to the power 1, 2. So only 2 are there, so 3 to the power 2, and C is let's take 5 to the power 1, 2, 3, 4. So 4 number are there, so we will take 5 to the power 4. So then we have to add 1 to their respective powers. After adding, we will multiply them. 8 plus 1 into 2 to the power plus 1 into 4 to the plus 1 equals to 9 into 3 into 5. 9 into 15. So there are 135 number of factors for the given number 14,40,000, and here the number 135 is odd. So if there are odd number of factors, then the given number will be a perfect square. So another important note is here that this is 135 number of factors including 1 and itself, that is itself is 114,40,000. So this is also included in the number of factors. Suppose in the competitive exams, if they asked to find the number of factors for 14,40,000 excluding 1 and itself, in such cases what we have to do is when we get that number of factors 135, we have to deduct two numbers, that is 1 and itself, we have to deduct them, and then the total number of factors will be 133 after excluding 1 and itself.